Today we're going to talk about logarithms. We'll learn about what this word means and calculate expressions like log base 2 of 8, log base 2 of 8 plus log base 2 of 16, and even work with things like equations. Some of these things will need log laws, and so we'll talk about that too. The word logarithm actually comes from two Greek words. The log bit comes from logos, and the arithm bit comes from arithmos. Logos means ratio, and arithmos means number. In this case, ratio actually is referring to the base, and number is referring to a product. So when you think about 2 to the power of 3 equals to 1 times 2 3 times, this equals to 8. This 2 is the base, while the product is the 8. And so when we say log base 2 of 8, we're asking the question 2 to the power of what equals to 8? And so that answer would be 3. In other words, logarithms are trying to find the index. Based on that definition, it's useful to know that log a of b equals to c can be rewritten into an exponential form as a to the power of c equal to b. So if we're ever given a logarithmic equation, we can always rewrite it into an exponential equation by recalling what the concepts do in each section. So for example, if they gave us log x 8 equal to 3, then we could rewrite it as x to the power of 3 equal to 8. And the 8 can be separated as 2 to the power of 3. And when you compare these, we can see that the x must equal to 2. Or if you're given log 2x equal to 4, we can rewrite that as 2 to the power of 4 equal to x, which means x is simply 1 times 2 4 times. And that equals to 16. So this law can be pretty handy when you need to solve for x. Another law worth noting is the addition and subtraction ones. So if you had two log expressions adding each other, keeping in mind that they have to have the same base, then the products can actually multiply each other and written as one single log. And similarly, if it was a minus instead, then you would just divide them in the order of which one's minusing which. So for example, if you had something like log base 2 of 8 minus log base 2 of 16, then this can be rewritten as log base 2 of 8 divided by 16, which equals to half, and so that's log base 2 of half. And just like index laws, these laws can also go in reverse. So if you had something like log base 3 of 9x, you can separate it as log base 3 of 9 plus log base 3 of x, which simplifies a little more to 2 plus log base 3x, because 3 to the power of 2 equals to 9. But going backwards on these laws isn't really that practical. Usually we use them to simplify into a shorter expression. So this will be quite useful if you get a longer expression with multiple things involved, like log base 2 of 16 minus log base 2 of 8 plus log base 2 of 32. This can be simplified step by step by saying the minus means 16 divides by 8, and so log 2 of 16 divided by 8, that will eventually add this other log here. So this would simplify to 16 over 8, which is 2, and so that's log 2 of 2 plus log 2 32. You could simplify this into just equal to 1, because log a of a equals to 1. Anything where the base and product matches is always 1. But it'll be more beneficial for us to merge these two together. Otherwise, we won't be able to do much with this here. And so log 2 of 2 times 32 would then simplify to a single expression with a single product of 64. Alternatively, you could work these out separately and add the results together. So there's a few ways to do this. But sometimes this might be the best option depending on what you're trying to solve for. Another common type of problem you might face is solving for x. So for example, if you had log 2x plus log to 8 equal to 5. There's not much that can be done about this 5, but these two can be merged together because of a log law. So we could say log base 2 of 8 times x equals to 5. And now we can use the conceptual conversion of log into an exponential equation such that 2 to the power of 5 equals to 8x, and 2 to the power of 5 is 32, meaning x would equal to 32 divided by 8, which is 4. So I hope that all made sense to you guys. Let me know what you think down in the comments below if you found my explanation on logarithms helpful. And if you did find this helpful, then please like the video so that YouTube can recommend this to other people. You can join the channel by clicking the subscribe button down below and ring the bell so that when the next video comes out, you'll get notified about it. Thanks so much for watching, guys. Have a good one, and I'll see you next time.